Next experiment is fourth experiment, that is write an Arduino program to interface soil moisture sensor. This also you can do hardware simulate. You can simulate it on the Tinkercad, and you can also do description using Arduino Kit and that sensor. So I will show you how to simulate. Okay, you can do the same program. It will work for in the description also. So open the Tinkercad account, create circuits. So place on Arduino to search for soil sensor, soil moisture sensor. So in the simulation, actually the model available, it has these pins. Okay, VCC, ground and signal. 3 pins are there. So VCC you can connect to 5 volts. Ground connect to, you can connect to any ground pin. So I will connect the top, this one only. So ground always use black color, VCC use red color, and signal, for that we need to write a code here. So this is a default code, replace, and you have to type this program. So in this program, constant int sensor underscore pin is actually A1. These are the analog pins. Okay, sensor puts you have to give here A0, A1, A2, A3, A4, A5. Any one of this you can use. So I'm using A1 here. Okay, it is connected to the signal. It should be connected to the signal pin. That is A1. And we are in the setup. Actually, we have to configure. Since we are in this program, we are actually displaying the output in the serial window. So we have to set up the baud rate. You can set up 9600 or 1,15,200, like that you can set up. So let me check with 9600. Serial capital S, serial dot small b, begin 9600. This is actually, we are going to set up the baud rate. Okay, number of bits per second. So in the serial transmission, we are transmitting at a baud rate of 9600 bits per second. So in the another function while loop, we are actually reading moisture. So we have to display decimal point also. So you can declare float moisture percentage underscore percentage is a continuous one word. Then int sensor analog. Where sensor analog we are configuring as input. Int is a name. Integer type. Sensor analog is equal to, okay, this int now sensor analog is equal to analog read. So we are connected this sensor to pin number A1. So we are reading that, and that will go to the this variable sensor analog. After that, we can also print serial dot println. What is the sensor output coming, that we can display in the serial window also. After that, we have to convert into percentage. So moisture percentage is equal to that value, whatever value we are reading from this, okay, analog read, that value. If I drag this, you are going to get maximum of 876. So this multiplied, this divided by our maximum value of the sensor output into 100. Okay. For example, if sensor analog is giving full maximum of 876, 876 by 876 is 100%. If it is 0%, any analog value coming divided by maximum value into 100. Then we can print 2 messages on the serial window. Serial print moisture percentage is equal to, that line will be printed, and is equal to also will be printed along there. Next, we have to, this calculated value, moisture percentage we calculated using this formula, that value you have to display. After that, serial print slash n means 2 times new line, will be taken, or you can write slash n ln here only. Okay, print ln also you can write here only. If you want only one time, 2 lines means you have to write slash and slash in 2 times. Delay of 1 second. So this is the code, and still I have to connect this signal to pin number A1. You can give the color green color, purple, or any one color you can use. Any one color you can use. So we used only these three pins. Now we can simulate this. Start simulation. Code is there. This code you have to type there. And to open the serial window, there is a serial window here. You click serial monitor. I think you're getting 0. Analog, this sensor analog, no? It is reading from analog sensor pin. That pin is A1. So it is first it is printing serial print analog value. That is this one 0. And after that, after the calculation, 0 divided by 76 into 100 is giving percentage serial moisture percentage is equal to, it is printing. After that calculated value it is displaying. Now how to vary? Actually in the hardware we can add some we have to insert this one to the part. Okay, this one you have to insert into the part, and if I add some water to that soil, it will soil the conductivity of these two will be resistance actually going to change, and difference between these two will result in we are going to give the analog value. Okay, actually it is going to calculate resistance of this potential difference. It will calculate and it will display analog value. Okay, so in the simulation, how to do this means once you start simulation, you click here somewhere. If you click on this, you will get this. So this is less water. Here it is full water. So for less water, it is coming 0. Okay, if the land is fully dry, you will get 0%. If I increase this, drag this, now you can see 12. So now 12 divided by 876 into 100 will give you 1.37%. Similarly, increase this value. You get 272, 640, 440. Now it is coming 50%. Analog, that sensor output is now analog value is 442. We declared as a hint. That's why it's coming integer value 442. After that, using this formula, we are calculated and displaying in percentage. Similarly, what is the maximum value of sensor? You can see maximum value of sensor is 876. So 876 is that's why the denominator we have taken sensor analog divided by 876. For this, it is giving 100%. If this fully the soil is watered, then it will give 100% moisture. If the sand is fully dried, you will get 0%. So in the simulation, okay, this dragging. If I click on this, it should be running. Once you start running, click anywhere in this portion, it will get this slider. So you can drag water level less, water level more, any value. So correspondingly, you will get the output here. Okay, this is the program number 4th A. Okay, thank you.